Preparing for a full-stack developer interview? You've reached Interview Guide, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a REST API for a product listing page with filtering, sorting, and pagination? I would expose something like get/products with query parameters for category, price range, search, sort, page, and limit. The response should include items plus metadata like total count, current page, and next cursor if using cursor pagination. On the backend, I validate inputs and ensure database indexes match common filters. On the front end, I handle loading, empty, and error states cleanly. For large datasets, cursor pagination is usually safer than offset pagination. While answering, focus on resource naming, query parameters, pagination strategy, response shape, status codes, validation, indexing implications, and how the front end consumes loading, empty, and error states. Question 2. What happens from the moment a user enters a URL in the browser until the page is rendered? First, the browser resolves the domain through DNS, opens a TCP connection, and usually negotiates TLS. It sends an HTTP request to the server, which returns HTML, CSS, JavaScript, and assets. The browser builds the DOM and CSSOM, combines them into the render tree, calculates layout, paints pixels, and runs JavaScript. Caching, compression, CDN usage, and minimizing render blocking resources can dramatically improve this flow. Make sure to cover DNS lookup, TCP TLS, HTTP request response, server processing, HTML parsing, CSSOM, JavaScript execution, rendering pipeline, caching, and where performance bottlenecks commonly appear. Question 3. How do you handle authentication and authorization in a full-stack application? Authentication verifies who the user is. Authorization decides what they can access. I store passwords using a strong hash like bcrypt or argon2, never plain text. For sessions, I use secure HTTP-only cookies. For JWTs, I keep expiry short and use refresh tokens carefully. Backend middleware should enforce roles or permissions on every protected route. The front end can hide UI, but the server must always be the source of truth. In your answer, talk about login flow, password hashing, sessions versus JWTs, token storage, refresh tokens, role-based access control, middleware checks, HTTPS, and common security mistakes. Question 4. What is CORS, and how do you fix CORS errors correctly? CORS is the browser mechanism that controls whether one origin can call resources from another origin. If my frontend at one domain calls an API on another, the API must return headers like access control allow origin. For non-simple requests, the browser sends an options preflight first. I fix CORS on the server by explicitly allowing trusted origins, methods, headers, and credentials. I never solve it by disabling browser security or allowing every origin in production. Be sure to mention same origin policy, preflight requests, allowed origins, methods, headers, credentials, why disabling browser security is wrong, and how server-side configuration should be environment-specific. Question 5. How would you choose between SQL and NoSQL for a new application? I choose SQL when the data is relational, consistency matters, and I need joins, constraints, and transactions, such as orders, payments, or inventory. I choose NoSQL when the access patterns are document-oriented, high volume, or flexible, such as activity feeds, event logs, or user preferences. The key is not popularity, it is query pattern and consistency requirement. Many real systems use both, SQL for core business data and NoSQL for scale-heavy features. While answering, compare schema design, relationships, transactions, query flexibility, scaling patterns, consistency needs, data evolution, team expertise, and examples where each database model fits better. Question 6. What are database indexes and how can they improve or hurt performance? An index is like a lookup structure that helps the database find rows without scanning the whole table. If I frequently query users by email, an index on email makes that lookup fast. But indexes are not free. They consume storage and slow inserts, updates, and deletes, because the index must also be maintained. I check query plans before adding indexes, and prefer indexes that match real filters, joins, sorting, and high selectivity columns. Make sure to cover how indexes speed reads, B-tree hash concepts at a high level, composite indexes, write overhead, storage cost, selectivity, query plans, and avoiding over-indexing. Question 7. How do you prevent common web security vulnerabilities in a full-stack app? I treat security as layered defense. For SQL injection, I use parameterized queries or ORM bindings. For XSS, I escape output and avoid dangerously injecting HTML. For CSRF, I use same-site cookies or CSRF tokens when cookie-based auth is used. Cookies should be HTTP only, secure, and same-site where possible. I also validate inputs server-side, add rate limiting, keep dependencies patched, and use headers like content security policy. In your answer, include XSS, CSRF, SQL injection, authentication flaws, secure cookies, input validation, output encoding, prepared statements, dependency scanning, rate limiting, and security headers. Question 8. How would you improve the performance of a slow React or frontend application? I start by measuring with Chrome DevTools, Lighthouse, and the React Profiler instead of guessing. Common fixes include code splitting, lazy loading routes, compressing images, reducing bundle size, and avoiding unnecessary re-renders with memoization where it helps. For large lists, I use virtualization. I also inspect network waterfalls, cache static assets, and remove blocking scripts. The goal is better perceived performance, not just cleaner code. Be sure to discuss measuring first, bundle size, lazy loading, memoization, unnecessary re-renders, virtualized lists, image optimization, caching, network waterfalls, core web vitals, and profiling tools. Question 9. How do you manage state in a modern front-end application? I avoid putting everything into one global store. Local UI state, like a modal open flag, stays in the component. Server state, like fetched products, is better handled by tools such as React Query, because caching, refetching, and loading states are built in. Truly global state, like user session or theme, can use context or a lightweight store. URL state is useful for filters and pagination because it stays shareable. While answering, separate local UI state, server state, global app state, URL state, and form state. Mention trade-offs between context, Redux, Zustand, React Query, and component-level state. Question 10. What is the difference between server-side rendering, client-side rendering, and static site generation? Client-side rendering sends a minimal HTML shell and lets JavaScript build the page in the browser. Server-side rendering generates HTML on each request, improving first load and SEO, but adding server work. Static site generation builds HTML ahead of time, making it very fast and cacheable. Hydration then attaches JavaScript behavior. I pick based on freshness, SEO needs, personalization, and traffic patterns. Many apps mix all three. Make sure to cover initial load, SEO, interactivity, build time versus request time rendering, hydration, caching, infrastructure cost, and when frameworks like Next.js make each option practical. Question 11. How would you implement file upload in a scalable full-stack application? For scalable uploads, I avoid sending large files through the application server when possible. The backend can generate a signed URL, and the frontend uploads directly to object storage like S3. I still validate size, type, ownership, and permissions server-side. Then, store metadata in the database. For user experience, I show progress, handle retries, and support cancellation. For sensitive files, I add scanning and private access controls. In your answer, cover multi-part uploads, file size validation, mind checks, virus scanning, object storage, signed URLs, metadata persistence, progress UI, retries, and avoiding storing large files in the database. Question 12. How do you design error handling across front-end and back-end? I use a consistent error contract from the API, usually with a code, message, and optional field-level details. The backend logs full diagnostic information with a correlation ID, but the client receives safe, user-friendly messages. Validation errors should map clearly to form fields. On the front end, I centralize API error handling while still allowing feature-specific messages. I also distinguish retriable errors, like temporary network failures, from permanent business rule failures. Be sure to mention consistent error response formats, HTTP status codes, validation errors, logging, user-friendly messages, correlation IDs, retriable failures, centralized front-end handlers, and not leaking sensitive internals. Question 13. How would you implement real-time notifications in a web application? I choose the simplest real-time approach that meets the requirement. For infrequent updates, polling may be enough. For one-way server updates, server-sent events are simple and efficient. For bidirectional features like chat or collaborative editing, I use WebSockets. I authenticate the connection, handle reconnects, and design messages to be idempotent. At scale, connections may need a pub sublayer, so events reach users across multiple server instances. While answering, compare polling, long polling, server-sent events, and WebSockets. Include scalability, authentication, reconnection, message ordering, fallback behavior, and when real-time is actually necessary. Question 14. What are transactions, and why are they important in backend development? A transaction groups multiple database operations so they either all succeed or all fail. In an order flow, I may create an order, reduce inventory, and record payment state together. If one step fails, I roll back to avoid inconsistent data. ACID properties give reliability, especially under concurrency. I keep transactions short and avoid external network calls inside them, because long transactions increase locks, contention, and deadlock risk. Make sure to cover ACID properties, commit and rollback, race conditions, isolation levels, deadlocks, payment or inventory examples, and keeping transactions short to reduce locking issues. Question 15. How do you use caching in a full-stack application, and what problems can it introduce? Caching stores expensive or frequently accessed data closer to where it is needed. The browser can cache static assets, a CDN can cache public responses, and Redis can cache computed backend data. I define clear cache keys and TTLs, then think hard about invalidation because stale data is the main risk. For hotkeys, I may add locking or background refresh to prevent cache stampedes. Caching is powerful. In your answer, discuss browser cache, CDN, server-side cache, database query cache, Redis, cache keys, TTLs, invalidation, stale data, stampede prevention, and read-heavy workloads. Question 16. How would you structure testing for a full-stack project? I follow the test pyramid: many fast unit tests, fewer integration tests, and a small number of end-to-end tests for critical flows. Backend tests should cover services, validation, database behavior, and API contracts. Front-end tests should cover components, user interactions, and edge states. I avoid overmocking where integration matters. In CI, tests should be reliable and fast enough to run on every pull request. Be sure to cover unit tests, integration tests, API tests, end-to-end tests, test pyramid, mocking, database fixtures, CI execution, critical user flows, and balancing confidence with speed. Question 17. How do you approach CI/CD for a full-stack application? My CI pipeline runs linting, type checks, tests, and build steps on every pull request. Once merged, CD promotes the tested artifact through environments like staging and production. Secrets come from a secure vault or environment manager, not the repository. Database migrations need special care, ideally backward compatible. For deployment, I prefer rolling or blue-green releases with health checks and a rollback plan. Shipping safely matters as much as shipping quickly. While answering, include source control workflow, automated tests, linting, build artifacts, environment variables, database migrations, deployment strategies, rollback, monitoring after release, and separating staging from production. Question 18. When would you choose a monolith versus microservices for a product? I start with a modular monolith unless there is a strong reason not to. It is simpler to develop, test, deploy, and debug, especially for small teams. Microservices help when domains are clear, teams need independent deployments, and scaling requirements differ significantly. But they add network failures, distributed tracing, data consistency challenges, and operational overhead. The best architecture matches team structure and product maturity, not fashion. Make sure to discuss team size, deployment independence, domain boundaries, operational complexity, data ownership, communication overhead, observability, startup speed, and why distributed systems should solve real organizational problems. Question 19. How do you monitor and debug issues in production? I want observability before there is an incident. Logs tell me what happened, metrics show trends, and traces connect requests across services. I use correlation IDs so a front-end error can be followed through back-end calls. Alerts should be tied to user impact, not random noise. During debugging, I check recent deployments, error rates, latency, and dependencies. Afterward, I write a blameless postmortem and improve detection or prevention. In your answer, talk about structured logs, metrics, traces, dashboards, alerting, correlation IDs, error tracking, health checks, performance baselines, incident response, and learning from postmortems. Question 20. A user says the application is slow. How would you investigate it end to end? I first clarify what slow means. Page load, API response, interaction delay, or a specific user flow. Then I reproduce it and check whether it affects all users, one region, one browser, or one account. On the front end, I inspect rendering and network waterfalls. On the back end, I examine latency, logs, database queries, and external dependencies. I form a hypothesis, test it with data, fix the root cause, and add monitoring. Be sure to describe reproducing the issue, identifying scope, front-end profiling, network timing, back-end latency, database queries, infrastructure metrics, logs, recent changes, and forming hypotheses before changing code. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.